Welcome, everyone, to chat about sustainable brick making with Friendly Water for the World. This is a special re-recording of our chat that occurred on Friday, June the 5th. We had some technical issues, and so the first half of the chat, we are doing a re-recording, and we'll be able to plug in the back half of the chat with the conversation we had with the attendees. So please enjoy this first half, and let's get started. So this is just some housekeeping that the participants received, asking them to mute their microphone, to feel free to ask questions through the chat, or if they would like to join in, they're welcome to interrupt the presentation. We're happy to have that conversation as ideas pop into people's heads. The chat is being recorded and recorded again, and all chats can be accessed at friendlywater.org/events, or if you're already familiar with our YouTube channel, you can visit there and see all the videos that we've recorded so far. This is chat number 11, and we're pretty excited to get going. One thing to note, our website is currently under redevelopment, and so you'll be noticing a lot of changes for that over the next few weeks. Again, please feel free to contact me. I'm will@friendlywaterfortheorg. I'm happy to answer any questions, and greatly enjoy hearing from anyone whenever something happens to pop into their head. One note: to attend the next chat, you must register for the chat. This is the last webinar in the ongoing series. And then we're going to be starting new webinars every week, so that you'll want to register for each week, so that that webinar can be placed on your calendar for easy access. All right, today's speakers are going to be myself, Will Forrester, Marketing Communications here at Friendly Water for the World. Wayne did speak at our chat on Friday. He won't be joining us for the re-recording portion, but you'll hear his voice towards the end on the previously recorded version. And then Tom Culhane, a current hydrogeologist and former soil scientist, will be helping us get into the nitty-gritty, so to speak, of soil and brick making, soil being kind of the most important component and element to brick making. So who is Friendly Water for the World? We are experts in village scale technologies, whether it's sanitation and hygiene or brick making. We build knowledge and resilience in communities that need it the most. We activate community engagement. We're not a passive partner, nor are we interested in short-term transactional relationships. We believe in building deep and meaningful relationships with our partners in the field. We embrace the dignity, strengths, and rights of all living beings, which are often the three elements that are most missing in the communities with whom we partner. And we always stand with the most vulnerable. So sustainable brick making. Here's a little video that I wanted to show that describes kind of the current environment, and it's reflective of most of the countries and communities in which we work. And it's a really great setup to help understand the situation that we have in front of us. So I'll get this started.
Traditionally, houses in Africa were built using clay and wattles. For hundreds of years, these have served as the primary building materials used in house construction all over the continent. But things are changing. About 20 years ago, clay-fired bricks arrived on the market. These are handmade, dried in the sun, and then fired in huge kilns that can be seen lining the roads all over Africa. In spite of their growing popularity, these bricks have severe limitations. They are uneven in shape and require lots of mortar to construct a good wall. They also have to be transported from where they are made to the building site, with many being damaged in transit. The low quality of these clay-fired bricks also means that they cannot be used in other applications, such as sanitation projects or water storage. The clay is dug from wetlands which are drained and then excavated. Using a wooden mould, the bricks are formed and then left to dry in the sun for several days. Once dry, they are carried to the roadside and made into piles, often containing as many as 15,000 bricks. The sides of these piles are plastered with wet clay to keep the heat in, but they are far from efficient. Most damaging of all is that they have to be fired using tons of increasingly rare tropical hardwood. In all, the process usually takes about 3 months, and the finished product is often cracked, misshapen, or unevenly fired. Not only do these bricks provide poor and expensive building materials, but their manufacture has a disastrous environmental impact on Africa's dwindling hardwood forests and wetlands.
Enkutu zijja mukono, kabembe, mayiro nga 8, 15 bwe zityo. Kisinziira ku loole gye tuba tufunye. Tufuna loole ennene emitwalo 15, ttani nga 5. Ettanuulu ng'eno egenda mu loole 4, ziri loole 4, ez'emitwalo 8.
In countries where it can be difficult to find work, brickmaking has become something that anyone can do, as long as they have the raw materials.
Ekintu ekizibu ennyo kujja ttaka wansi eyo okulituusa waggulu, n'ekyokubiri kyanku kuba enku nzibu nnyo mu kugula kwazo, ate n'amaanyi g'okozesa kuba kati wano enkuba ng'etonnya oba tosobola kulisambira wansi wabula oba olina okukwata kitiiyo n'olitiya ne lidda waggulu.
The fires are kept burning for 24 hours, often with new wood being added. Although only a fairly recent phenomenon, brickmaking of this type has already had an unsustainable impact on Africa's forests.
Ttanuulu kati nga weeri awo oyinza okugifunamu kale amagoba ng'oggyeko byonna sente z'okozesezza, oyinza okufunamu amagoba mitwalo nga 10. Noba ng'osobola ate okwongera.
The phenomenon of firing bricks is relatively new. It's probably in the last 15 to 20 years that people discovered that you could actually make bricks cheaply without compressing them and then fire them, and then you would use them to build houses. And of course that required vast quantities of firewood. The problem of deforestation in Uganda is a serious one. We used to have vast hardwood forests, what we used to call tropical forests or rainforests, but most of them have been felled, they have been cleared. Desertification is with us. It's now known that the Sahara is moving southward at a rate which I think some people estimate at 20 kilometers per year. So if we keep cutting down trees, the other consequence is desertification, because we'll have no rain, the soils will be washed down, and what will remain are the bare rocks, or whatever little there is will turn into sand.
So the Sahara is moving south at 20 kilometers per year. I think that's a pretty eye-opening statistic. And so that's the environment in which we're working and which people are living. So there's a huge opportunity here, an opportunity to produce a building material that is more reliable and sustainable, to use a process that is lower cost and at least equal to being low tech, and that's more local. An opportunity to help the climate and help the environment, and certainly through better building materials to build more resilient schools and clinics and other buildings. And now that brick making has become an income source, a job for several people, many people, there's definitely an opportunity to hopefully expand on that, or at least maintain what's already there. So the solution we have encountered, and we've got many projects now, we're rolling this out and testing it, is an interlocking soil stabilized brick press. Here's a picture of one, and it's similar to a compressed earth block press, and people kind of use brick and block somewhat interchangeably. The difference between the ISSB and the compressed earth block typically is two things. There's a stabilizer, usually cement, that will go into an ISSB, and it also contains ridges, which you can kind of see in the background. There's some bricks there. You can see the ridges there. So an ISSB press is a manually operated machine. It produces a compressed block. It uses leveraged pressure. It's one person pulling down on a handle to remove the air and bind the ingredients together. The machines are produced fairly locally. We've purchased them both from manufacturers and also had them built. They can be constructed by good metal workers. So far they've been costing us somewhere between $600 and $1,500 depending on the source. They can be run by 2 people, but they tend to be, it's more efficient to have at least 3, and 4 is often typical. Very few moving parts, so they're easy to maintain, and they use very basic ingredients, just soil, a stabilizer, and a little water. So the process, and it's a fairly straightforward process. You analyze the soil composition, you sift it as necessary, you combine it, you mix it, you add a little water to make it wet. You pour that mixture into a mold, press the mold, and extract the brick out of there, and then you stack it to cure it for 7 days. And so at this point, I'm going to hand it over to Tom Culhane, our soil scientist. He's going to be able to get much more in depth and talk about one of the most important ingredient for this process, which is the soil. So Tom?
Hi. So one of the key things to making a strong brick is to have the proper soil. So I'm going to talk about that a bit. All soils are made up of sand, silt, and clay. And if you rub your hand over a moist sample of soil, if you feel grittiness, that's the sand. The silt's got kind of a floury texture, and the clay tends to be sticky and very smooth. And the goal, as you can see by the last bullet here, is to end up with a soil that has, the initial goal actually is to have a soil that's 75% sand and 25% silt and clay. The reality is you're allowed a fair amount of latitude within those goals, and you can compensate either by adding more sand if you have too silty clay of a mixture, or you can add some cement that compensates for some of that. And I'll talk about that in a minute. But to determine the texture of your initial soil, there are a number of field tests you can perform. I've described 4 here. The ball and water test is simply that you roll a ball in your palm and a moist ball of soil. Then you tap it with, you put it in one palm and you tap your other hand underneath and you kind of whack your hand. And if after 10 hits by your other hand, the moisture rises to the surface. That tends to tell you that the soil is too coarse, because that means you've got a lot of sand grains which have a lot of porosity between them, so the water can move more freely. Or if it takes more than 30 hits to bring the water to the surface, that implies that it's too tight of a soil, too much silt and clay. So that's one test you can run. Another test is simply to create a thread, and that's where you either on a flat surface like a table or between your palms, you kind of roll it back and forth until you get a elongated cylindrical thread. And if that thread is, if it breaks before you reach 5 centimeters, then it probably has too much sand in it. No, actually, I think it's 3 centimeters. Anyway, the next test, which is the ribbon test, that's actually the more common test that most soil scientists would use. That one there, basically, again, you roll something like a cigar-shaped sample of soil, and then you place it between your thumb and your forefinger, and you kind of squish it out you advance it in front of your forefinger, and if it can stick out, if it breaks before you reach 5 centimeters, then that means it's too sandy. It doesn't have much strength. But if it sticks out more than 30 centimeters, then it's probably got too much silt and clay. Anyway, the last test is the jar test. That's the one most people can most easily identify with. There, all you do is take a straight-sided jar. You put about half soil and half water in it. You put on the lid, you shake it vigorously, and then you let it settle. And after 30 minutes, the bottom layer will be the sand. Next layer that would settle above that would be the silt, and the clay would probably stay suspended in the water. And you measure it, because all these percentages I'm talking about here, they're all by volume, not by weight. So you can literally measure the thickness of those three different, well, particularly the sand and the silt, and then the remaining water, and that's basically your ratio of sand, silt, and clay. Okay, next slide. So once you have your proper soil, this gives you the percent of cement that you add. So if you were able to obtain that perfect ratio of 75% sand and 25% silt and clay, then you'd normally add about 10% cement. If you've got a sandier soil, then you can actually go a little bit lighter with that. If it's a siltier or clayey soil, then you can add a bit more cement. So one thing I do want to talk about, though, is that one thing people can actually do in the field to conserve cement, since cement's going to be the most expensive ingredient, is lower down on the wall where the rain is going to splash up against the wall more. You can use a higher percentage of cement, and then higher up on the wall where it's not going to get splashed so much, you can use a lower percent. And that low percent, even if it's a fairly silty clay, you might be able to get away with maybe 5% cement or something, as long as it's well protected from the rain. And this is a good opportunity to mention that that's an important thing when building a structure out of soil cement stabilized blocks, is that you will need a strong roof overhang or a significant roof overhang over that wall to protect it from rain, because that's one of the things that will break down the bricks most quickly. But anyway, once you've got the, and the other thing, as I mentioned before, is if your soil ends up being not quite the percentage you want, in other words, if it's high in silt and clay, one thing you can do is sift some sand in a separate pile and figure out how much you want to bring up the percentage by volume, and then add that amount to the sand to the soil, mix it dryly, and then add the cement at that point. So, for instance, if you had a soil that was low in, it had too high of a content of silt and clay by 10%. If you could add 10% straight sand to that sample, you can bring down that percentage. But anyway, once you've got all your dry ingredients mixed, then you add water slowly until it's the right consistency. And the test for the right dampness of soil that you're going to make your brick out of is simply that you form a ball of that soil cement mix with water. So that's everything combined. And you should be able to squeeze that clod in your hand, and it should form a round clod shape, but it shouldn't stain your palm. If it's staining your palm, you've added too much water. If it doesn't hold together, then you haven't added enough water. Okay, next slide. So once you've prepared the proper mix of soil, cement, and water, you place it into the mold portion of the press, and then you squeeze the long, or you pull down on the long handle. And then these machines are pretty slick because they're designed to compress the brick to just the right pressure, and you'll actually know it, and you feel the handle kind of click when you've reached the right pressure. And then you push the handle in the reverse direction, and it actually ejects the brick. And then you carefully remove it, because it is very fragile at that point. You stack it off to the side, and then you have to let it cure slowly. Particularly if it's hot, you have to sprinkle some water on it to slow the curing process. And I read different things as far as when it's actually through with the curing process. Some seem to indicate that you could actually start stacking the bricks after 7 days. One of the more conservative articles I read said 3 weeks, and I'm sure all this depends on the temperature. But basically, I think it's a minimum of a week before you can actually stack the blocks. And the last thing I'll mention is we had I'm not an expert in using this machine. My only experience was during a training that we had in Anacortes this last summer. But I really was impressed by these bricks. They're incredibly quick to put together and are much more environmental. Okay, Will?
Thanks. One quick question. What happens to the bricks if they cure too quickly?
If they cure too quickly, then there's a fair chance they'll crack, so they won't be as strong.
Okay. Well, let's talk about the benefits. And there's probably more than I could fit on one page. In fact, I'm sure there's some I've left out here, but these are certainly a number of the large benefits. They are, these ISSB bricks have great production value. 4 men can produce at least 300 a day. Their interlocking shape means they only need mortar at the very the top and the bottom of the bricks. The ridgers make it easier for bricklayers to lay the bricks. It goes much faster. The bricks are more uniform in size, shape, and properties. Means they usually perform better. They're less likely to degrade, or they're less likely to rot. They produce just visually a much nicer, smoother finish. They look quite good as a wall. They have equal to better strength than fired clay bricks, and they can control temperature better because in the morning they do a great job of absorbing the humidity in the air, and in the afternoon slowly releasing that water that's being collected in them into the air around them, so that the temperature can be 10 to 15 degrees lower than a similar clay-fired building. The materials are sourced locally, which is fantastic. You cut down on all that transportation. And then the machines themselves can be moved from one place to another. So you can, bring the equipment to the site, bring the tools to the site, rather than having to do it somewhere down the highway or in the woods, and then bring all that stuff inside to the site. And then probably most importantly, especially when you're trying to stop the Sahara heading south at 20 kilometers a year, it prevents desertification and preserves the natural habitat. So you don't have to chop down all the beautiful forests to build these intense fires to fire this brick. That all goes away. So let's talk about some recent ISSB projects that we have. We've got about, I think, 13 machines in different communities at this point. Here is, we have two different styles of bricks that we'll show. This one has got the long ridges. That's probably most typical. These have holes in the middle, so they act both as a way to interlock the bricks, but also you can put rebar down the center of these bricks for added strength. And here's kind of another version of that kind of brick, and you see it being extruded out of the press here. This is a house that was being built in Tanzania, northwest Tanzania, I believe, and you can see just how well these bricks fit together. You notice there's mortar at the very bottom, and there'll be mortar at the top, but in between the bricks themselves, there's no mortar. Sometimes you will need to put mortar on the corners, just for added strength at the corners. But you can tell just by looking at this how much faster it must be to actually lay these bricks. And also visually, you know, it's a really nice smooth finish, and it's a great looking style of building. And here's Kennedy from Cleo, one of our partners in Tanzania. And they've done a great job so far doing some training for some of these machines. Here's another brick making press in Uganda. And you'll see you'll need two people, one on one end and one on the other. It helps to have another person to pull that lever down and squeeze out all of that air and moisture. And it will lock in place once you have it down as far as you need it to go down. And you can see in the building behind them, the regular style of bricks that are used with these kinds, and the building to the right, you'll notice that they've also put mortar on the outside of the bricks. You do not need to do that with ISSB bricks. They have a much better insulating value than the clay-fired bricks. And you'll also notice, just as a side note, the smoke coming out of that building there's a kitchen, it's kitchen smoke. It's one of the reasons why rocket stoves, another one of our technologies, is so useful in this area to drastically reduce the amount of smoke and pollutants that come out of cooking, and that kills so many people through their lungs and affect people's eyes. Recently, it was late last year, we had a train the trainer in Minova, Congo. And it was when several of our trainers came together and built bricks for community there. Here's a demonstration in India. We had some local folks fabricate a brick making machine for us in India, and that looks good. It was actually a much lower price than what we've typically been paying. And here they are. It's a recent trip from our co-founder David Albert, and you'll see Renal Funk in the background there. They made this trip to India in February, I believe, and dedicated a building there. And they were demonstrating several of the technologies as well while they were there. This picture, a couple of pictures, are from bricks that have been built recently, I should say bricks that have been pressed recently for a school in Goma. Here they're curing, at least in one part of the curing process right now, and then also probably being shielded from the elements. And then our most recent training in Manze, Zambia, and you can see the bricks that were produced during the training. Those are outstanding looking bricks. Very smooth finish, very uniform in shape and size. You can see they're, just visually, they're a much better product than the clay-fired bricks. And here's Eric Lajodi, our programs manager. He was at the training and showing off his brick making skills. And another, as they're stacking the bricks here, and you can just see how well they stack, how uniform they are. And here is, this is actually at a brick making site where they're going to be building a new school. And this is post-training. This is where the folks, community members that we have trained have taken these presses to a different area where there's another school for the Zambia Women's and Girls Foundation that they're building. And currently those school children are just meeting under a tree. You'll see the slab there. That slab is there for the school, and then all the bricks for the walls. Looks great. And then this one final picture here. When you're given an opportunity, I'm sure, to create something of permanence that's stable and strong, it's just such a great benefit for any community. And these bricks have been a big hit everywhere we've gone so far. So that's the presentation. We will switch over to a Q&A, and the rest of this video will be the remainder of the original brickmaking chat that we had on Friday the 5th. So thank you very much for joining us, and please enjoy the rest of the chat. Just bricks needed mortar between them. They typically don't. That's evident in the picture that Wayne shared about the house that was being constructed. You will find sometimes, though, in the corners, that mortar is added to the corners of these buildings. But in a straight wall, you wouldn't need to have mortar vertically.
Yeah, that is what I was referring to as post and beam construction, where they will pour posts at intervals of 12 to 15 feet apart, and then do an infill stack of bricks. And at the very top, they will pour a concrete beam across the top to tie all the bricks together.
I wanted to answer Deanna's question. She asked, let me catch it here, whether you can use the bricks for water storage tanks. The answer is it's marginal. I mean, you can use them. We've checked with 2 engineers, and no more than 5,000 liters. And most of the tanks we build are in the 20,000 liter range. Basically, because the force of the water will be forcing against the walls of the water tank, and they may not be strong enough in the long term to do that. We have seen them used that way, but only for tanks that are 5,000 liters or less. We do use the bricks for the bases of the water tanks.
But we need fired bricks for the main part of the water tanks.
Oh, no. We don't use bricks at all.
Now, the water tanks that we're building are referred to as ferro cement, and they start with a wire cage and a second layer of chicken wire, and then it is wrapped with a reed fence, and people climb on the inside and plaster 2 layers over the course of 2 days. Then the reed fence is taken off, and then 2 more layers over the outside, so that wire is embedded within the wall of the tank.
Yeah. Thank you.
I have a couple of questions.
Yeah, because that one doesn't give you a person.
You showed different forms. Is one form forms? Does the machine itself have different mold forms that you can switch in and out, or are they all separate machines?
So far, they are all separate machines, and it only depends on who the local manufacturer is. We've ordered several machines from Makiga in Kenya, in Nairobi. They are an interlocking both horizontally and vertically. We've used the other type in Rwanda that's stacked with Lego with hollow cores as well.
And do you find anything better, or than the other, or are they good for different purposes?
The only advantage I see over the hollow core brick is they might be lighter. Number two, you can put vertical rebar in them. And number three, you can join them at 90 degrees at the corners easier than you could with the tongue and groove brick. But each has its own advantages and disadvantages, and they're very marginal.
Do you when the ones that have the hollow cores to put rebar in, do you then fill that hole up with cement, or just the rebar is just because it looked bigger than a rebar, the hole?
Yeah, I agree. I do not know of the use of cement core or rebar in the construction with those that we have built. Mm-hmm. That doesn't mean that it cannot be done. And I would certainly do that in an earthquake-prone area.
Okay, and I'm sorry to dominate, but I do have another question that I see someone else has asked something similar. What about a ring beam? Is that needed around the top of a building? I'm working with a community that wants to build a 2,000 square foot approximately clinic. And the other question I had, so the ring beam, is part of the potential design. The other question I had is with the other bricks that are made locally, just the regular soft kind of clay bricks, because they're not very strong, you often see these buildings in Uganda that have columns all the way around. And then I was told by a civil engineer that those are basically there to support the roof, because the other bricks are not strong enough to support the roof without those columns. And the columns are made with rebar and cement and all that other thing. And so can you dispense with the columns?
No, I'm not an engineer. And what you are saying makes sense, that your building will be stronger with cement columns and a ring beam or a concrete lintel over the top. That just makes common sense to me, although we do know that there are buildings, homes, individual homes being built without either. That would be something you can pass by an engineer.
Yeah, I don't think Richard's Center in Uganda has columns.
It does.
It does.
It does. It does on the corners.
On the corners, yeah.
And at intervals of, I would guess, 12 to 15 feet from what I recollect.
That's and I was told that even if we bought fired bricks for the building, we'd still need columns on the corners, and in other areas. But the original design had them very close together, and so thinking that trying to avoid that, and if these bricks, so an engineer would look at it and decide on the strength.
Yes. Yeah. Where's this being built?
That's been done in your knowledge of the strength in terms of holding up the roof without these additional supports.
Say again. I
there's
missed the question.
That you know of. That was another question that somebody asked.
Well, I know that engineers do test blocks. We're trying to get an engineering test done with blocks in Madurai, India.
Okay.
And there are mechanical engineers that can do that. Maybe Eric Lajodi, do you know of tests that the government does for these bricks? Or Lidwin?
I would presume that Makiga probably has some testing data in
I was
Nairobi.
going to say, when I was Googling this a couple days ago, I came across an article where they tested the strength of these bricks. So I can send that to you, Wayne.
Okay, thank you. And maybe we could send it out as well as part of the video at the end.
Yes. Sorry.
It would be great to get more information. Thank you.
Okay, yeah.
Hello.
Eric, did you have some comments? No?
Yeah, I just wanted to comment and say that actually it has been confirmed that when you do construction using the interlocking blocks, the cost of construction reduces drastically. And you just asked about the tests that are usually carried out on these particular blocks. I can remember clearly within the Kenyan government, we have what we call the Ministry of Housing is also recommending the use of these interlocking blocks. And I'm sure they have already carried out the tests and they're recommending that they are good actually for construction of houses. In fact, currently, I know most of the government buildings that are not in story form are being constructed using the interlocking blocks under the Ministry of Housing. And the tests, I'm sure, that have been carried out also by Makika, the company that is producing the interlocking press machines in Nairobi.
And the school being built in Zambia was approved by the government engineers as well.
Yes.
Is there someone in Uganda producing these machines?
I know that
The
Makiga
government are
sells them.
inspecting the school in Zambia as we're building it. So they are checking on it as we go along.
Thank you, Deanna.
What were you saying? I mean, in terms of Uganda, is someone making these machines?
Makiga in Nairobi has a sales office in Kampala.
Oh, okay, great.
Or a representative there.
Other?
I have a question.
Go ahead, Pearlie.
Has anybody been putting in any plumbing or electrical into the walls or into the buildings with the bricks?
Good question.
I do not believe so. I believe that would be run on the surface or on interior walls.
Okay, thanks.
Do all of the constructions require and utilize that base of concrete all around underneath? Is that typical, or is that necessary for all of the construction?
Yeah, it needs to have a proper footing to support. And I assume that in some cases, engineers might allow the embedding of certain interlocking bricks in that footing to reduce costs, but I am not absolutely certain.
I think Lidwin was coming in to speak a bit earlier, but I'm not sure.
I don't see her now. She may have been saying goodbye. She's not online. Oh, there she is. Lidwin, did you want to offer something?
Yeah, it's really interesting to see the interlock. It's very interesting to see, but in Tamil Nadu, in Madurai, they have built a two-story building with this interlock bricks, and it is very
very beautiful it is looking, as well as it is very strong, very modern technology they have used. And more than 5 years since the building is, but so far no damage or anything. But they have painted the outer wall, so that will varnish it, so that gives a natural color, and it looks very beautiful. And we as such in Gandhikram, we had the experiment, but we have not started working. And the brick which we made was little too heavy it was. So we asked the engineer to make it a little smaller to handle the brick, so that it will be easy to carry, you know. So still we have to work on it. Next month we are going to have a training, and prepare the experiment by ourselves first, then we will give the training to other trainers. So thank you.
Thank you. That's a great update. Any other questions or comments? Hey, Eric, I sent you a message directly, if you would check that out. All right, so I'm going to final screen here just to share. There we go. Okay, so just some final words. Thanks everybody for participating and joining us again this week. If you have an idea for a future chat, if there's something that we haven't talked about that you'd like us to talk about, whether it's directly related to a project or something that's broader, please let me know. We're definitely interested in sharing things that, whether we're experts in them or not, just having an open forum for discussion. That's kind of what the chat's all about. I will say that I'd like this quote, "The only riches that last are the ones that are given away." So please share our chats, or share the links or Facebook posts or emails or whatever you, however you want to share them with folks who you may think might be interested, whether they're affiliated with us or not. We just love to grow the community and get more folks engaged. And we also ask that you, if you are a donor, if you're interested in becoming a sustaining member, that's our monthly membership, and that can be as small or as large as you like. As you're all probably aware, these have been hard times, and as David has mentioned, we've definitely cut our budget for this year. But the sustaining members really help us plan for the future, and they also provide a good view of the support we have for other donors as well, especially for foundations who may be interested in our base of support. And it's a great way to demonstrate the folks that we have who are engaged with us and who are amazing supporters. And finally, please don't forget to register for next week. Again, you will not have any more of these chats automatically placed on your calendar. Today was the last one. You'll receive an invitation for next week. And so if you'd like to attend, please register for that. We'd love to see you again. And I want to wish everyone a great week. Thanks very much to Wayne and to Tom for joining us and speaking. We really appreciate your expertise. And thank you everyone else for participating and sharing your questions and comments. I hope you've enjoyed this as much as we have. So thanks very much, everyone, and we'll see you next week.
Thank you, Will. I'm enjoying all of these chats. They're very informative.
Great. Thank you, Kathleen. Bye-bye now.
Thanks. Bye.
Bye.
Thank you. Bye.
Bye. Thank you.
Bye now.
Bye.
Thank you.
Bye, thank you.